Hi students, welcome back to my channel. Let us learn properties of ionic compounds today. First, let's go through the definition. They are compounds composed of ions held together by electrostatic forces. They're also called as electrovalent compounds. So let's take this example. Um, NaCl. See, NaCl is a combination of two atoms, sodium and chlorine. Sodium is metal, and we all know that metals have a tendency to donate electron. That is, they are called as electrovalent elements. So, electropositive elements. Electropositive elements means the metals which have a tendency to donate electrons. So, once they donate electrons, they gain a positive charge. Similarly, chlorine, on the other hand, they are non-metals and they have a tendency to accept electron and they get a negative charge on them. So they are non-metals are called as electronegative elements. Okay, so now if you observe this compound NaCl, it is obtained by combination of the two atoms sodium and chloride. That is, sodium gets a positive charge and becomes cation, and chlorine gains a negative charge and it becomes anion. So this type of interactions, whenever they are present in a particular compound, they become very, very, very strong bonds. Okay, that's the reason why they are called as electrostatic force. And whenever there is electrostatic force, remember students, that the entire compound will be very strong. That means with respect to any physical properties like melting point, boiling point, so it will always be high. Okay, similarly, I've given one more example, KBr. Now let's go through some of the properties. The first one is physical nature. They are solid and are hard because of strong forces of attraction between the positive and negative ions. So as I already told you, because they are made up of the two types of ions, cation and anion. Cation is one wherein the metal gets a positive charge, and anion is one wherein the metal gets a negative charge by accepting electrons. So whenever this type of arrangement is observed, we call them as electrostatic force of attraction. And because of this electrostatic force of attraction, the particular compound becomes very hard. Like for example, NaCl, KCl, KBr, CaCl2, etc. There are many types of ionic compounds, examples. So they are all very hard and they are solid. Now, the second point, they have high melting and boiling points because of their interionic attraction. So, I want you to understand by looking at this structure of NaCl, is called as the lattice structure. Now, in this lattice structure, you can observe carefully that the green atoms are chlorine and the silver atoms are sodium. So you can observe students how the arrangement is present within one structure or one crystal of NaCl. So you can see the entire arrangement with all the bonds between sodium and chlorine, and similarly between sodium and sodium. So this entire lattice structure is very intense. Okay, they have shown just one fragment. So like this, you can imagine several more millions of fragments like this. And you can imagine now if you try to heat NaCl, why is it that the melting point shoots up to around 1800 degrees Celsius? That's because every bond between the lattice, it has to be broken literally. Okay, so only when it is broken, it is able to um, melt, or it's able to undergo the aqueous form. Okay, so that's the reason why their melting points and boiling points are very, very, very high. Okay, now let's go to the next point. So I've given some of the examples. For NaCl, the melting point is 1074 and boiling point is 1686 degrees Celsius. And for calcium chloride, melting point is 1045 and boiling point is 1900. Similarly, for calcium oxide, melting point is 2850 and boiling point is 3120. So you can imagine, students, how high the melting and boiling points are, just because we can understand it with the help of the lattice structure. Now, what you have seen here, it's for NaCl. Similarly, you have lattice structure for each and every compound. For CaCl2, you have lattice structure. Calcium oxide, you have. MgCl2, you have. Are you understanding? So there are many types of lattice, and each lattice gives a different melting and boiling point. Now let's go ahead with the third property, that is solubility. They're soluble in water and insoluble in organic solvents. So as we all know, the nature of solubility, that polar dissolves in polar. So because there is a difference in electronegative value, sodium chloride, if you observe, sodium and chlorine, they are different types of elements, right? Because sodium is metal and chlorine is non-metal, and they have huge difference in attractive forces. So we call that as a polar molecule. Now, if you try to dissolve a polar molecule, for example, NaCl in water, water is also polar. So naturally, there is a tendency for these compounds, that is ionic compounds, to completely dissolve in water, because as we all know, the nature polar substance dissolves in polar solvent. Similarly, non-polar substance dissolve in non-polar solvent. Okay. Now, the last one is going to be properties of ionic compound. In my other video, I have explained in detail about conduction of electricity. Please go through that. So here it says that ionic compounds conduct electricity in molten form due to presence of ions. See, whenever we talk about conduction of electricity, the main criteria, the two main criteria is that there has to be free electron, and the second thing is that there has to be mobility of the electron. So whenever there's mobility of electron and whenever there's free electrons in a particular circuit, okay, or in a particular electrolytic cell, then the conduction of electricity and conduction of heat also becomes very very easy. So that's why. And since you already know that when you talk about an ionic compound like NaCl, right? So the compounds divide to form Na plus and Cl minus, and Na plus moves towards one terminal, that is called as the cathode, and chloride will start moving towards the other terminal called as anode, and hence there will be complete movement of electrons, okay, within the electrolytic cell or within the beaker, and it will conduct electricity. Okay, so these are some of the major properties of ionic compounds. I hope it was useful. Thank you so much.